All right. Hey, everybody. I'm Josh Avant, and today I'm here to talk about functional reactive programming in Swift. It's a fun new thing that you might have seen has sort of started to pick up some momentum in the Swift world. So functional reactive programming, FRP for short, I've built a whole app from scratch with this, and I can say it's the first time I've ever used this pattern. It's been a joy to build. It's an interesting way to think about how your app works, and has added a new dimension of sort of functionality that I've never played with before, and it really brings a lot of life to your app, which I'm really excited about. So let's dive in. So let's start from the top. What is functional reactive programming? Functional reactive programming is a synergistic combination of two things. Functional programming, get ready for it, reactive programming. These are two separate design approaches that happen to go together really well. Like peanut butter and jelly, together they're better than the sum of their individual parts. So let's pull these apart, starting with functional programming. Functional programming is a style of programming that completely revolves around functions. Because everything is a function, there's no state. There's no member variables, there's no self-dot. It's just input, output, and a function. It's a very composable approach because you can just keep chaining together inputs and outputs and just put them together, and every unit of work is one small encapsulated unit. And this is also one of the big features of Swift. You've actually done functional programming when you've implemented a map or a filter function. You have a collection, you apply a map block to it, and then out comes your whatever. This is a whole field of study by itself, and I won't go any deeper than this because that's all we really need to know for now. So now that we have that down, there's one more component to FRP, and that's the reactive part. This reactive programming can be described in three main parts, and this is what I really want to focus on in this talk. Observing streams of data, transforming them, and binding the result to some output. So let's dive in on what these are. Streams is the first one. If you think about it, a lot of the development work we do revolves around streams of data. Common examples that you might recognize are watching a text input as these are types, checking for valid characters, certain substrings, waiting for the user to complete a form, and then making sure all of their inputs are appropriately configured, waiting on a network request to complete and give us the data we need, waiting for a delegate callback to happen, watching for notifications of fire. In FRP, streams are a first-class feature. Everything in that list is a stream. The most important aspect of FRP is everything's bound to time and not memory. So everything has to do with when something occurs. It's explicitly stateless. Events happen, and then nobody cares anymore after they happen. They're done. It's like things coming down a pipe. Like once it comes through the pipe and you don't catch it or do something with it, it's gone. It's passed. So now that we have data moving in sort of this stream, this like pipe mentality, what do we do with it? We transform it. In FRP, streams get transformed. This is one of only two things you can do with streams. The other one's in the next slide. And this is precisely where the functional programming I talked about earlier comes in. So for example, you have a stream, it generates a value. And then like Swift, we would attach a map function to it. That allows us to convert this stream into something entirely different. And also like Swift, each time we transform something, we get a new value from it. In this case, a new stream. So now we have something coming in, we change it, and now we have a stream of like something different now. We'll never modify an existing stream. Streams are taken, things come out, and they're done. And you can, like I'm saying, you can transform them and create new streams. You can also chain them together. And as we'll see, that's a huge advantage of FRP. Each time we transform our data, we do so using this individual specific component that makes it small, easy to manage, and very testable, which are all good things. So let's do a quick little interactive demo of streams and transformations. We're already at the demo. So I'm a visual learner. I love this. It's called RX Marbles, rxmarbles.com. It's basically a big site. There's a sidebar over here that I've zoomed is out of zoom, but it's this little JavaScript widget, and it sort of lets you play with various functions. And so the one we have right now is called merge. So let's take a look at this. 1 second here, I got some notes on this. So time flows from left to right, and this is the timeline of an observable. Each of these arrows is time going on, and one arrow is what's called an observable. These are items emitted by the observable. If I can get my mouse. These are all items emitted by the observable. The 20, the 40, the 60, the ones, all these. And then this transformation, this is the transformation we talked about. This is a merge transformation. So what happens is we have stream 1, stream 2. We apply a merge to it. And as I mentioned, we don't modify existing streams. We create new streams. This is our output stream. And this transformation is a merge. So of course, you get a single stream with all of these events from these two. And the cool thing about it, remember, this is time. So this could be text input where the user's typing something. And this could be your password input. And you want to make sure they don't, maybe you want to make sure they don't put in an emoji. So you could create an merge stream and then hook this up to another transform that just checks for emojis and fails and pops an alert message if an emoji was detected. That could be one real-world application of this right here. So this is sort of a visual representation of what we're talking about when we talk about streams and events and transforms. So let's go back to the presentation. So now we've seen how FRP allows us to, in real time, transform the data however we want it. But what do we do with that? How is that useful? Well, the next one is bindings. This is the second thing we can directly do with streams. In FRP, streams will inevitably end up with some destination assigned to them. Transforming a stream is, of course, optional. Like you don't have to apply a function to a stream. But in general, you're always going to bind it to something. Otherwise, you're just calculating data that doesn't go anywhere. These destinations are called bindables. And the key here is bindables are usually UI-related things, like a label or a collection view. So bindables and this concept of binding data to like receivers replaces all the calls we typically make to setters to update the UI. So you're not going to call set text, set hidden, set enabled, update with JSON. We just take the data that's coming in as it comes in and connect it to sort of what configures the UI. And then we're done. And then as data changes, the UI also changes. So we no longer have to write these functions that update a button label or update the hidden. It just happens when the data happens. So let's go back to the demo. And this is the fun demo, because here's where we're going to do some live coding. So let me mirror my monitor real quick here. All right. So let's start off with how you might usually do something in a regular way, which is, by the way, that's called imperative. Imperative is generally the style that's the opposite of reactive. Bigger, absolutely. Okay, so for our demo, we have this sign-up form. We want to show an error if the email address is invalid. We want to also show an error if it's not 8 characters. And also, because we want to make sure the user can't do something that they're not really ready to do yet, we want to make sure the sign up button is disabled until everything passes validation. So to start, I've got some helper functions here just to let everybody know this is just stuff that's going to be working for us in the background as we code. We have our standard isValid function. It's going to check the email address with a predicate, make sure that it passes, and return a Boolean, basic stuff. We have an isValid password function, make sure it's greater than equal to a minimum length, return a Boolean, basic stuff. And a function to show our alert, nothing crazy so far. So let's implement this the way that we would probably normally go about it. So we'd start in Vue.load. We probably want to observe the text field for the editing changed event. And then sort of like when somebody types a letter, check to make sure what's going on and set the errors and set the sign up button that we talked about. So let's set up, well, that function would be this. Text field did change, takes a text field, and returns a bool. So what we're going to do is, actually doesn't return a bool. We'll just have text field did change. It checks everything and sets up all of our stuff. So we're going to observe the text fields, tell it to call ourselves, give it the selector we want. Text field did change. Let's kill this. And then for the control events, editing changed. And we'll do that for the password text field. Okay, so now when the user types in any characters in any of the text fields, text field did change gets called. We can check if the password fits our specs, if the email address is valid, and also enable disable the sign up button. So we got the text field coming in. Let's check if the email address is valid. So we have that function I told you guys about earlier. The email address. We'll just go ahead and connect it to the email address text field. So now we have a boolean, email address is valid. Let's do the same for password is valid. Send it to the password text field. And then, so now let's set all of our UI based on what we get from these. If the text field, we got was the email address, let's update the warning label. So email address hidden is this. Yeah, if it's valid, we want to hide the warning label. So let me pull over the UI to show you which label I'm talking about. So this is the warning label. If the email address is valid, we want to hide that. And we're going to do the same for the password label. If we got a password hidden is password is valid. And then we want to, remember we said we wanted to enable or disable the sign up button if everything's valid. So email address is valid and password is valid. So now we got it. Let's give it a shot. Let's do it smaller. Can you guys see that? A little bigger. 75. Yep, that works. Okay. So josh@josh.com works. Password 1, 2, 3, 4, 5, 6, 7, 8 characters. That works. Don't know where it went. And then the sign up button. So that's normally how we would do this. But how would we?
Sorry, you're hiding the text field, not the warning label. Yeah.
Ah, yes. Thank you. That's why I disappeared.
Error
I really want to hide that text field. But take my word, it works. It would do the same as the email warning label, where once we got to 8, it would hide the warning label. So that's how we would probably implement that normally. But how would we do this in Reactive? So let's go ahead and comment out this file, and I've got another file here where I'm going to redo this. So first we'll start off with the text field. In Reactive, so I'm using RX Swift right now. That's the framework that enables me to do all this stuff I'm about to do now. And that also gives me an extension. It swizzles it on, but it's okay. You can trust this one.
Is that a third-party thing, or is it?
Mm-hmm. RxSwift, there's a huge community behind it. It's available on GitHub. You can grab it. It's got a whole lot more that I'm going to show today, but it's one of a couple frameworks that are available to you if you want to dive into this.
It's just a Cocoa button?
It is. And I'll go over these again at the end, sort of like some options you can look into if you want to dive into this. So it gives us this Rx text field, and this Rx text field is an observable. It's the arrow thing that I pointed to earlier in the Rx marbles. It's going to give us the stream of event. It's going to give us as the user types a character, it's going to give us things coming out. So what we want to do is we want to map that to our Vue controller's validation function like we did. So what we've done here, like we did with the example I showed earlier, this is effectively what our merge does. This is the merge that I showed earlier. This is the function that sits in the middle and creates a new stream. And this new stream is simply a Boolean. So the only thing that's coming out is a Boolean. So now we take that Boolean and we simply bind it to the warning label. So now what's going on here is as the user types something, it fires into the map, which runs the isValid function, returns a Boolean, and then sets that value to hidden. And we're done. Every time the user types in the text field, it's going to recalculate and reset this value. And I'm going to do this because I won't cover this today, but you can figure this is like memory management right here. And we're going to do the same on the password text field. We'll map it. View controller is valid. Password. Pass it in. Bind it. We're going to bind it to the password warning label, to the hidden, clean up, and boom. We've got the password field is now hooked up, and it'll hide the warning label as the user's typing as appropriate. And now, but what about the sign up button? The sign up button takes input from the email address and the password. So we'll take that. There's a combine latest function. So where we were doing map, RxSwift gives us this function called combine latest. And that does as it kind of sounds like it does. It takes two and combines them. It actually is, I don't know if it's officially the merge function that I showed earlier, but it's very, very similar. We'll take the text signal from the text field. We'll take the text field from the password field, and it'll run through here. So what we'll do for this, for the transformation block that we pass to this, we'll do view controller is valid. Let's call it email. And view controller. Maybe source kit's not doing well. Is valid. Password 1. So now the transformation block is taking the combined, and then it itself is returning a Boolean whether both of them are valid. And then we're just going to bind that to the sign up button enabled. And clean up. So as texts come in, we calculate whether all the fields are valid, and then we bind it to the enabled button, and it sets the enabled every time a character is set. So now this is our code, and this will do the same exact thing we did back there. And let's give it a shot to verify. So type an email address. Every time I type a character, this is firing. So as soon as the predicate I'm using looks for an @ sign surrounded by one character. So every time I fail that, it's updating, it's running this, and then it's setting the hidden value. And ditto for this. And just like that, the whole form works. And we don't have a function that's like calculating things. Let's go ahead and compare the two. If I can do this in a pretty way. I don't know if I will. Yeah, now it's time to make it smaller.
Sorry.
Let's do this. Can everybody read that? Mostly. So for comparison, we have this ViewDidLoad function. It hooked up a target that we had to manage. It called this function, and in this function, we were updating everything at once. Whereas this just updates things as specific events happen. It does less updating, and the updating itself is broken out into 3 different parts. More simpler parts is better than one big monolithic part that does everything. So, and also, it's significantly less code. We're at line 45, give or take. Yeah. So this is the difference between a reactive approach and this. We're also keeping state in here because we're calling up like the hidden value and resetting it every time, whereas this does it for us through the observable.
So this app is a great way to illustrate what it's doing and how it's working.
Mm-hmm.
But I'm trying to figure out when would you want to use this, because you probably wouldn't. Would you use this setup for that simple of an app?
Yeah.
Okay.
I would. So this is just a toy example to start thinking in terms of like streams of data and events. But this, you can apply this thinking across your whole code base, and when you it does require you to think differently. But once you do, you start noticing, oh yeah, that's a stream, and that's stream. So basically, and actually,
I'm trying to really pinpoint in my head the advantages of doing it this way as opposed to this way, and I'm sure you're implying that it's not just the amount of code.
Sure. So for this, take a look at this function. This is one big, huge function that's updating the whole view. But now we have one little function right here and does one specific thing.
Yeah, but isn't there a big function behind it in the RX Swift library?
That's across the fence in the RX framework. So that's not our concern. I mean, you're bringing in a framework, and I'll cover this later. I will admit it's a heavy framework, but that's sort of the beauty of RX. Is RX says like, listen, we know we're going to do these things, and we're just going to implement a generic way to do these things and give it to you. So let's hop back into the demo. And as you're getting to, this is just the beginning. There's plenty of patterns that fit very well in this. Delegates are the perfect first experiment with FRP. Delegates are very basic, but again with the signals and events, something happens and then a callback fires. So delegates fit very nicely with FRP. They refactor, kind of drop in pretty cleanly, and you can experiment right away with these. API clients are great. So what might happen in an FRP pattern with an API client? You'll call a function and you'll get an observable back, and then you'll just observe the observable, and then when it comes back, it fires, and you can throw away the observable when you're done. Versus the completion block method and like waiting for a block to fire, stuff like that. Session state managers are great. I have in my app, I have a layer that takes data in, and then so for example, you log in. And then I have like this layer immediately after login tries to fetch the avatar. But then all these things are listening for the avatar. So like I have the avatar in the tab bar, I have the avatar over here, and then whenever this other layer gets it, everything else gets it because they're all listening in. And then the holy grail is MVVM. This FRP allows you to sort of re-architect your app in an MVVM fashion, and that's out of scope for this one, but definitely worth looking into if you dive into FRP. Framework options. RX Swift is the one I showed you today. It's popular. It has a huge community. It is a big dependency, but I would encourage you that the juice is worth the squeeze. I was very worried at first about FRP and MVVM and all this reactive stuff, and now I love it. Now I'm like all in on it. So it's a little scary at first, but I promise it's worth it. Promise Kit, Bright Futures Interstellar. This is the Promises design pattern. It's not what I showed you, but it's a very similar idea. It's a lighter weight pattern if you're really concerned about bringing a big dependency. So it's a good idea to sort of play with the general reactive stuff if that's what you want to do. And that's it. The sample code that we worked on today is available on GitHub if you guys want to check it out. Yeah.
Can you comment on the response times? I mean, if I did a complicated thing where I'm analyzing a stream in two ways, how would the two compare? Do you have any metrics?
I haven't run performance measurements on like tight loops where something like firing a bunch. But I would say for the general use case across the app, I haven't really ever grappled with any performance problems. So
well, you wouldn't see them in something like
sure.
You did. But I mean, if you take that strategy of doing code and you apply it to you apply that code to automating a car.
Sure.
Okay, where it's a lot of data streaming in. Would that make sense then? Versus the traditional.
Honestly I don't know. I haven't measured it for like high data flow situations. I've only ever used it in like this kind of general applications.
So you can't see that yet.
Yeah, I can't really say.
Do you see a big increase in memory usage?
I don't. If anything, I'd say memory usage probably decreases because this sort of forces you to eliminate state. So you're no longer holding things like, oh, I gotta put this there so this function can use it and like process it. Everything kind of happens at once and then it's done. And it's all released. Which is good.
I have two questions.
Yeah.
What is it like to debug this stuff? Like when something's going wrong, where do you put your breakpoints and what's your stack trace look like?
So it's actually not bad because this forces you to sort of design discrete moments in code. So it sort of calls in the FRP paradigm where like something inputs come in through here, and then X, Y, Z happens, and outputs come out here. So when you stick to that structure, things are defined a little more. There's less state where you're like, well, where'd this come from kind of thing. Like you always sort of know where data's coming and going. You know where to look.
Based on like what's hitting.
Right. Things are like sort of constructed in very defined chains. So it hasn't been too bad. It can get squirrely if you have a lot of observers and like, but I would say you also want to try to observe putting yourself in that situation. So yeah, I would say it hasn't been bad.
All right. And so you said this kind of stuff is testable. How is your sample code there more testable than the version that you're saying is not as good?
Sure. So so for this function right here, you got a lot of stuff going on in here. You can test this, but you're testing a lot of different things. This one right here, you can insert a fake or a mock and just make sure that it subscribes right if you want. You can test just this chunk of code by testing the text field. Whereas with this, if you want to test just the text field, well, you can't really isolate the behavior of this. This does like 3 things. So if you want to test it, you have to test all of it. Whereas this does one thing. You can put specific input into the text field and make sure the right behavior happens. And then you're just testing that block of code. So it sort of allows you to break things up a little more.
What if the one on the right you just refactor it so you break it up and you have 3 functions that do specific things? So how is that less or harder to test or not as testable as something like this?
So that would be functional, right? You're broken into 3 functions.
Well, you're not chaining them together. You're just calling them. You're just kind of like organizing the code.
Sure. So yeah.
Technically, right?
Well.
So now you've gone to the dark side. It's just that easy.
So with this approach, there's one big huge input. You could break out these parts, these separate parts, but they still all sort of happen at once. And that part and parcel is a problem where you're doing a lot of things at once. Whereas this allows you to sort of like slice these parts up. So it's more sort of giving you the framework to break things down a little more.
All right. Well, what does a test look like? I guess that's what I want to know. For the one on the left, what does the test look like?
So the one on the left, the way I've tested it before is I'll put like invalid text into the text field, and then that'll cause the chain to fire, and then I'll make sure. So in this case, I'd make sure that the label is hidden, and then I'll put valid in, make sure it's hidden. But and then that's isolated to just these lines, and that will break. That test will fail if just those lines change. And I can do that here, but there's also, it would have to go through this function, and a lot of stuff's going on right here. So that change is, that test is tied to a larger block. It is testing the same behavior, but the test will possibly break if something wacky goes on in here and unrelated to the actual email address text field.
Sorry, so you write a test for view did load on this view controller. That would be the function you're testing, and you would just make sure that the output of this stuff came out the way you wanted.
I would trigger the view. So in test, I would trigger the view to load. I'd just call view, and then I would start throwing data in specific text fields and asserting the output of the text, like asserting the specific behavior.
So kind of like black box.
Yeah. Like I want to make sure if I put in nothing with an @ sign in the email address text field, that the warning label is up, and then put in something with an @ sign or whatever my predicate's checking for, it's going to be hidden. Does that answer your question?
Well, we could go all day. I mean, why couldn't you do that on the one on the right? It's the same thing. Then you don't have to test text field to change at all. You just test view did load and just make sure your button is enabled the way you want it.
Right. So the one on the right, we have two streams here, but we have no way to isolate this. We have two streams of events. So let's hone in on the sign up button example. The sign up button example relies on the input for both of these text fields. So you sort of have to hook both of these text fields up into one thing. Whereas on this one, they just emit, and you're just checking them real time, separate from changing the warning label and stuff like that.
I guess what he's trying to say is stylistical difference. It's different in style. I guess you can implement the same thing using an imperative way or reactive way, and you can test the exact same thing in both ways. It's just you will write that code in both ways. It's not probably the point you're trying to make is that it's not necessarily better or worse.
I think functional stuff is in general a little bit more testable because you're able to break things down. Like it's part of the design. It's like an anti-pattern in functional to sort of like meld things together. Whereas imperative lets you do stuff like this. Does that make sense? So I mean, you could break things up in imperative, but to some degree, this design forces you down a path that like makes you make sure everything is broken up.
Do you think that isolation in functional programming inherently makes it more testable?
It makes it more composable, I'd say, and I think that leads to better testability.
So, is there a downside of writing code like that? But the first thing that jumps to me is readability.
Mm-hmm.
Is that something you get used to in time, or?
I think so. Like I know. So in most of my Vue controllers, I have a bind Vue Elements method, and so I know that's the go-to place to figure out like what's going on in this Vue controller. So you're always thinking like, what signals am I dealing with, and like what outputs are going to happen. So it's a pattern, and you learn. Yeah, like you get used to like where should I look for that kind of stuff, and like the bindings encapsulate. It's nice too because the bindings encapsulate a lot of the logic. Like all of these bindings can be set up in one function. All this behavior can be encapsulated in one block of code, whereas this behavior sort of spans a couple of different blocks. So you have to know like, oh, this calls this, I have to jump over here. All of this is defined in one place, and so as far as readability, I definitely like that.
So another question: how much control do you have over the granularity of the stream callbacks? So, for example, we're getting something fired back every character.
Sure.
Right. So, if you're reading a byte stream from the network or something, and you don't want to do that, can you somehow tweak that?
Absolutely, and that is what RX Swift provides. It provides you tons of functions, and one of those functions is there is a Debounce, which, let's play with this. You can specify an interval where if a bunch of things happen in an interval, just wait and give me one. So this is, so for example, if you wanted to sort of rate limit somebody typing and just sort of check at the end, you could implement the Debounce. And depending on your thresholds, you get different ones coming through. And if everything happens at once, your output observable is only going to get, the one.
So how would the API look? Can you
What
in RX Swift, can you or CocoRX, can you show us the debounce method?
Sure. So yeah, that's the beauty of functional. We can implement it right here. Well, I'm getting the live coding territory, so let's see how this goes. So what I would do is I would debounce this time interval. So I want to wait for, let's say, half a second for that. Scheduler. Yeah, let's do this. Scheduler. Oops. I'm gonna be honest. So I actually use a different framework that has been deprecated. So I'm just starting to play with RX Swift. So I'm not totally familiar with the API. So I don't know offhand how to call that. See how it works. Doesn't like that. Scheduler type. Yeah. Yeah, let's just do that. See how that works. Oh no, don't like that either. But point is, if you wanted to add a debounce, it's as simple as dropping that function right in there.
And then it would call, like on that schedule, it would call map and then continue down the chain.
Mm-hmm.
That's pretty cool.
Yeah.
So that goes back to our idea of functional programming as inputs and outputs. So debounce is function and goes right through. There's no state. You're not accumulating it in a collection and then setting a timer and stuff. It's just give it the debounce, and you can really create some awesome chains. Some of the cooler stuff I've seen that I've been wanting to play with is if you have a table view or a collection view and you're scrolling through and there's a lot of image loading, you can actually set a delay and wait for the user. Like if somebody's flicking through and you don't want to fire off a bunch, you can set a delay and wait for them to stop for like 1/10 of a second, and you know that they're sort of slowing down or they have stopped, and only then trigger the image request. It's pretty fun.
You know, when you the apps that actually use the RX paradigm and code base.
Sorry?
Do you know any of iOS apps that actually use RX Swift?
I'm trying to think of some like trademark ones. I can't think of any offhand. I want to say the Artsy app, Ash Furrow and Orta, and they're using a bunch of RX. I use an older framework called Bond, which was deprecated. It's the fun of living on the edge, I guess. But I know there's a lot of people out there doing a lot of reactive. I think the Kickstarter app I think is very purely functional and reactive. But I think there's a wide community starting to use this.
What resources are you using to keep up with the crazy functional stuff? Wild West.
Yeah.
Blogs, anything, or like what?
That's kind of the hardest part. There's not like a central place for like reactive. The two folks I mentioned, Ash Furrow and Orta Thoreau, probably butchered that. They're both good folks to follow. Following a bunch of people on Twitter is a good way to sort of follow it. The RX Swift does have a Slack, community Slack, which is really good. So as you have questions, it's been a really great community to sort of like as I said, I've been coming up on this great community to sort of like learn in. There's folks on Slack that love helping, so it's cool.
So I guess for larger scale apps, it's kind of hard for the entire team to kind of just to make the decision to jump into Reactive right away. So I'm wondering if this thing you can do like gradually, little by little, like this chunk of the code or this little layer is Reactive. You can do the experiments there, and then it doesn't have to like the entire app doesn't have to adapt it.
Absolutely.
How it works.
Yeah. Delegates are the best way to start with Reactive because delegates, the pattern sort of maps directly. You're waiting for an event to come down the line. It's one event. It works one way, one direction. It's about as simple as you can get with all of the concepts of FRP, and it usually falls right in place. And you can sort of pull a delegate pattern out. And for what it's worth, I've never encountered a delegate pattern I couldn't convert into an observable. And I have a couple layers in my app where I implement a delegate pattern, or another layer implements a delegate pattern, and I just put a wrapper right over it that just converts it to an observable. So delegates, basically anywhere you set up a delegate is a great place to experiment with FRP.
You can use FRP to replace the delegate.
Right, you can replace it, or if you want to maintain that layer, maintain the delegate functionality in that layer, you can write a wrapper right on the, like you could set a layer to be the delegate and then expose an observable. So it would take the event and then emit an observable, and then your consumer layer would subscribe to the observable, and then now you're reactive. Now you're using reactive. Cool.
So I was looking into Futures Kit. I was at Allconf, and the guy who wrote it, he had a presentation that was pretty cool. It did some crazy stuff, and it would seem that you can do almost, from my basic understanding, it would seem that you can do almost everything you talked about the show just using that. Where's the actual edge for how much this kit does it?
So the edge in my mind is RxSwift provides a whole bunch of transforms. Futures is just like, hey, this is going to happen in the future. Here's the token, kind of thing. I'm not the expert on Future for sure. I haven't done a ton of Future, but I think I was at that talk.
Oh, you were there?
I think so.
Oh, cool.
And that's what I got from the talk and like other things I've seen and stuff. It's just like Futures is simply, this is going to happen in the future. Here's the API to react to it, and that's it. RxSwift, like I said, has a whole bunch of functions, a whole bunch of transforms and stuff in the marbles that lets you do debouncing and filtering and combining, stuff like that. So Futures is reactive, and then RxSwift is sort of an extension of all that. I'm a convert. I'm definitely a fanboy of the Rx model. I love like you can chain a whole bunch of stuff together and get like these really crazy transforms, and like the UI table view one is kind of a fun one, the loading.
Where does the functional end in the RxB, and functional is just like slicing your app into functions, like
So the functional is like this part where you're like map, bind, debounce, like you're just adding stuff in there, and it's the idea that like you're simplifying all of these, and the Rx framework provides you with that big list is all functions. You can just slide right in. Cool. Thank you guys.
Man, thanks.
So, yeah. I think we're done. Second speaker? No?
No, Mariana is.
Okay. Let's take a quick break. You guys wanna grab some more sandwiches? There are tons of sandwiches, and then we'll meet up again and do some discussions. Some heated discussions. Informative.
Are we gonna do this? Are we gonna put it on the board?
Yeah, Amazon Prime now.
Round table. What's that? Round table discussions.
Round table discussions without a table.
Without that table.
Yes.
Table. Okay.
Okay.
Because I have one of them.
That's
Yeah.
I think I heard it somewhere, maybe like Natasha the Robot's blog. It wasn't front and center on the blog post somewhere. It was just right after.
I have one thing. I love it before 48 transforms. Frequency domain.
I just just ready for
Okay.
I've been working for a year now. Alright. I'm almost like it's been a long slog and sort of like hand off.
Yeah.
So there's somebody that you handed that project off?
We just hired a guy like last week.
Well,
It's a perfect
I
time.
would love
It's
to
a
get
great
back
time,
into
like,
the
kind of put a bow on
scientific
it,
stuff.
give it to him, and sort of
I was
head out.
moving more towards doing
It's kind of like just new
iOS development,
projects.
and I started looking at the job
The
market.
company's
and
growing really
looking
fast. It's just one of those
specifically
things like
for
company goes fast,
scientific
where's it gonna
computing,
go?
and
So,
not
I wanna
finding
go a
a
different
whole lot. Not opportunities that would work for me. So I started working on
It's more like the direct. It's like you know, the company's really bigger.
really
it's
just to build my knowledge
we're gonna do this
and
now.
to have something I can put on my resume.
Okay.
You know,
Sometimes it
because
can be
goes to a
hard,
group of like
you know,
10,
with
15
defense
people,
background,
30, 40
you know,
different
what have you
things
worked
that
on?
change.
Really big computer,
Change
a
it
really big
right.
program.
Also,